Hello again, geometry. Here we go with lesson 5. So distance and midpoint. This can be as easy as just two separate formulas. But what I'm going to try and do is explain where they come from, kind of how you can think of them so that you don't get them mixed up, because that also happens. People do mix these up quite a bit. So in lesson 3, we found the lengths of segments using the segment addition postulate. What happens if that segment is on the coordinate plane? And maybe, for example, the first example, it's not horizontal or vertical. Okay, you're going to have to find another way. So what we're doing here is finding the exact length of AB and rounding it to the nearest tenth. Okay, the segment addition postulate does not apply in this example. So we need another way to find this out. We can use the distance formula. I'm just going to write the distance formula on the line. So D equals, the distance equals x1 minus x2 squared plus y1 minus y2 squared. Now, you might look at that and say, oh, that's disgusting. And you would be correct. I think the same thing. I'm going to show you, though, how the distance formula is simply, they are exactly the same, the Pythagorean theorem. In fact, the distance formula came from someone who said, I wonder if this would work, and figured out that the Pythagorean theorem can be manipulated to make the distance formula. And I'm going to show you how that works above. If you understand this, it's going to make doing this distance formula very quick and very painless. If you don't, it's okay. It's not like I'm going to test you on this. All right. So here we go. I'm going to go up to the picture and I'm going to draw a line straight down from B and a line straight over from A. And what does that create? Well, it creates a right triangle, right? Which means I can then do A squared plus B squared equals C squared. That only works with right triangles, which is what we have. Now, what are A, B, and C? Well, I'm just going to call this A. I'm going to call this B. Actually, you know what? I'm going to flip that. I'm going to put A down here. I'm going to put B here. It wouldn't really matter, but there is a reason for it for myself. Okay, so A, B, and C. So leg squared plus leg squared equals hypotenuse squared. Okay, now I'm going to solve this for C because that's C would represent the length of AB. Let me solve this for C. Well, I'm going to get rid of the radical or get rid of the squared. So I'm going to take the square root of both sides. So the square root of A squared plus B squared equals C. Well, what's another way to get A? Now I could use variables again, but I feel like it would confuse you a lot. So what I'm going to do is I'm going to go over here and I'm going to give the coordinates of A and give the coordinates of B. So A has coordinates -3 and then -4. B has coordinates 4, +3. Okay, so this point down here, which I'll just call C, that has coordinates of 4, -4, right? So how do I find A? Well, that's just a horizontal line, right? So I can subtract my 2 points there. Okay, so from 4 to -3. So basically what I'm doing is A, and we'll go over here and do this, A equals 4 minus -3. Rather than actually getting a number there, I'm going to plug that in. 4 minus -3 squared. Okay. B, I'm going to look at and say -4, and that's going up to the y value in B, which is 3. And that's going, I'm going to put that in here, -4 minus 3 squared. And you can see something that looks a lot like the distance formula. Okay. Now, I've got most of the distance formula set up. I'm just gonna go ahead and finish this one up. But that's how the Pythagorean theorem and the distance formula are related. Again, if that didn't make sense, it's okay. But I'm gonna continue now. 4 minus -3 is 7 squared. -4 minus 3 is -7 squared. And now what's 7 squared? That's 49. -7 squared is also 49. So the square root of 49 plus 49 is actually the square root of 98. Now it said exact, right? Exact means I want to break this down into its perfect squares, which we did back in Algebra 1. I'm going to go ahead and clear this real quick and go down to the bottom. Okay, and I'll show you what I'm doing here. So the square root of 98 is what we ended up with. I'm going to go ahead and break that down. That's 49 and 2. 2 is prime, so I'm going to circle it. 7 and 7. I have a pair of 7s, so that brings a 7 to the outside, a leftover 2. So that would be the exact length of 7 radical 2. If you didn't understand that, I did make a video on how to simplify radicals, but make sure you're asking in class as well. Right? The rounded answer here is 9 point, I think it's 9.9. Let me do it real quick. Yeah, 9.9. So that's the rounded answer, is 9.9. It's about 9.9 units long. Now, I'm going to show you a quick way of doing this. You can do the formula. All right, so you could do the formula. X1 is -2. X2 is -8. Oops, hold on, that's not a comma. Y2 is -1 and 7. Okay, you can do that if you want. You can probably see that there's going to be potential for a lot of mistakes. You got a lot of negatives going on. You got to be careful here. -2 minus negative, so that's -2 plus 8 is 6 squared. And then -1 minus 7 is -8 squared. 6 squared is 36. -8 squared is 64. 36 plus 64 is 100. Square root of 100 is 10. It worked exactly. Now I'm going to show you a quicker way. If you like this way, you can use it. But if you don't understand it, just stick with the formula. So -2 to -8. What's that change there? So if I'm looking at a number line from -2 to -8 is how many units? It's 6. I don't really care which direction you go. It's 6 units. Square that. Okay, plus what's the distance from -1 to 7 on a number line? So from -1 to 7 is 8 units. Look what you get. Same numbers. It doesn't really matter the sign because when you square it, it's going to be positive. Same numbers, and then you're going to end up with the same distance, which we got here. Right? So either way you do it is fine. I try to convince people that I like this way better, but I still have a lot of people do the whole formula, which is fine. Just got to watch out for those negatives, and it can get a little tricky. So that's distance. To the back, midpoint. It can be helpful to find the middle of something, especially in geometry. For example, if Billy got a 60% on the first quiz and a 90% on the second quiz, the middle or the average would be 75%. You know, like, need a refresher on what I did there. All I did was add up 60 plus 90. And because I'm looking for the average, divided it by 2. So 60 plus 90 is 150. Divided by 2 is 75. You do the same thing with the segments on the coordinate plane. It is essentially finding the middle or average of both coordinates. So you have to do the average twice. Right? So the midpoint formula, again, there is a formula. If you want to use it, feel free. But if you remember average, it's going to remind you to add. Here's what I see a lot of people do. They will do x1 minus x2 because that's what you do on distance. But it's add here. y1 plus y2 divided by 2. If you remember that it's average, though, average always means add, and that will remind you of what you should do. Now, one thing I do want you to notice, I'm going to point it out, the answer for finding length, which was on the front of these notes, is a number. Length is a number. Or length or distance is a number. With midpoint, though, the answer is a coordinate. It's got two numbers in a point form. So parentheses, number, comma, number, close parentheses. That's how the midpoint answer is going to be given. All right. A couple examples with midpoint. Find the midpoint of the segment. So what I want to do is I want to name these segments or name these points. So that's 2, 5. Make sure you get these right. If you get these wrong, it's going to mess up everything. -3, -3. Okay, so I'm going to find the average of the x's. So the x's are 2 and -3. I'm going to add those up and divide by 2. Then I'm going to find the average of the y's, which is 5 plus -3 divided by 2. Now I'm just going to simplify both. 2 plus -3 is -1 over 2. 5 plus -3 is 2 over 2. I'm going to simplify if I can. -1/2 does not, so I'm just going to leave it -1/2. 2 divided by 2 is 1. And there's my midpoint. Now let's just make sure that that lands on the line. -1/2, so half of a unit up 1. And that is right there, which makes sense. Okay. QS has endpoints of 3, 5, and 7, -9. Find the midpoint of QS, and then find QM to the nearest 10th. All right, so let's first find the midpoint. All right, so that's just average of the x's. So 3 plus 7 divided by 2. Then you've got the average of the y's, 5 plus -9 divided by 2. 3 plus 7 is 10 divided by 2. And 5 plus -9 is -4 divided by 2. So 10 divided by 2 is 5. -4 divided by 2 is -2. So the midpoint is 5, -2. Now it says find QM. I didn't focus on this on the front. When I just say find QM and there's no symbol above it, what I'm saying is find the length of QM. I think I did talk about it back in segment addition postulate, but I want to make sure I point that out again. We're trying to find the distance or the length of QM. Now, notice I'm saying QM. I'm not saying QS, QM, what I just found. So the 2 points that I'm using for this are Q, so 3, 5, and M. 5, -2. Make sure you read what I'm asking you to find. All right, so QM. Now, you can do the formula all you want. I'm going to do what I just showed you on the front, on the front side with the quicker version. I want you to try to see that. What's the distance from 3 to 5? Well, that's 2 units, right? Think number line. And what's the distance from 5 to -2? Think number line. Well, that's -7. And now I'm just going to do that. 4 plus 49 is 53. So the square root of 53 is the distance. And I said to the nearest 10th, so I'm just going to type that in the calculator. Square root of 53 is going to be 7.3. Okay. All right, almost done. The midpoint of Kn is 3, 4. One of the endpoints, we'll just call it K, has coordinates -3, -2. Find the coordinates of N. All right, there are a couple ways to do this problem. It's a little bit tricky. First thing I'm gonna do is you don't have to do this. I'm just gonna try to show you what's happening here. So 3, 4. That is the midpoint, right? It says the midpoint is 3, 4. So I'm going to put M here. K is -3, -2. So K is all the way down here. N is the other end of this segment. Well, this segment, KM, needs to go the other past M somewhere up there. We don't know where. We're trying to figure that out. Okay. So I'm going to come back to that here in a second. Actually, no, I'll do that first. This is what I call the reasoning method. You're reasoning through what's happening here. So from K to M, I'm looking at the X coordinate only. How far do I have to go to get to M? Well, I was at -3 on the X axis, right? So -3 here. And on the midpoint is at 3. So how far did I go? I went 6 units. Well, if M is the middle, I've got to go 6 more units, X direction. Well, I'm starting at X equals 3. So this right here is X equals 3. And I got to go 6 more. That's at 9. So the X coordinate is 9. The Y coordinate, I started at -2 and went up to 4, right? It just happens to be the same distance here. So it's 6 as well here. It doesn't always work out that way. It just happens to be that way here. And this is the number 4, and I need to go 6 more this way, which 4 plus 6 is 10. So that would be my other endpoint, 9, 10. That's the reasoning method. A lot of people don't like that method. They don't see it very well. I'm going to show you the algebraic method as well. Okay. We don't know N. I'm going to call it X, Y. We don't know what that is. Well, the midpoint formula says you add the two endpoints. So in this case, it would be -3 and X. I'm going to add those up and divide by 2. And that's going to equal the midpoint X coordinate. So the midpoint X coordinate was 3. Okay. I'm going to set up another equation just like that using Y. So the Y coordinate was -2 plus Y divided by 2. And that's going to equal 4 when I'm done, because I know what the midpoint is. Now I'm just going to solve both of those. Multiply by 2. So I get -3 plus X equals 6. Add 3, I get X equals 9. Matches. Okay. Next one, multiply by 2 again. -2 plus Y equals 8. Add 2, I get Y equals 10. Either way is fine with me. Just make sure you understand one of them. And that's it.